Okay, in this lesson, I'm going to reteach the lesson we did on stem and leaf plots. So this is the study guide that you get when you go into 1.2.1 prior to the quiz that you take on 1.2.1 on Apex. It says that you can learn about stem and leaf plots from your textbook. The textbook that Apex uses is not the textbook that we have access to at Redington. So let me go over this with you. We're asked to construct a stem and leaf plot for this data. It looks like we have presidents and possibly their ages at death. So what a stem and leaf plot is it's a way that we can view data. It's a type of distribution, a type of graph, basically, that we can see the shape of the data, but we can also see the specific values in the data. The stem part of the stem and leaf plot is all of our numeric values minus their last digit. So looking at our data set here, we have all 2-digit numbers. So if I take off the last digit, the ones place, we're left with just the numbers in the tens place. So 6 for 60s, 7 for 70s, and so on. When I create my stem, I have to include every number between my minimum part of my stem and my maximum. We couldn't say skip 5 if there's no 50s in there. It has to be there. It has to show that shape of the distribution. For the leaves, I'm just going to add the ones place in order for every piece of data within this data set. So when I do that, I have, let's see, 46 is Kennedy's age. And then the next person, the next youngest person, let's see, is Garfield, who is 49. So I put a 9 there. And now on this part of my stem, my 4 is the 40, so I have 46 and 49. I can see there's 2 pieces of data within this stem. And I just continue that. So for the 50s, there's a 53, a 56, a 56, a 57, and a 58. And as I do this, it's best practice to make sure that you cross off the ones that you've already included so that you don't repeat anything. And if you accidentally skip one, you'll see it in the end. I already have this written down, so I'm going to keep putting those in here. 60, 60, 63, 63, 64, 64, 65, 66. There's 3 people who were 67 and a 68. I'm going to pause this while I add the rest of the data so you can see what it looks like. So now that my graph is complete, I can see the shape of this data is mainly pretty much symmetrical. I can see that most of my data is within the 60s range, and I can specifically see what those values within that range is. On the next part, it says you might notice that the stem we used in the last question is a little crowded with leaves. Sometimes when our data is crowded like this, we might be able to see a more accurate picture of the data by creating a stem and leaf plot with 2 lines for each stem. What that means is I'm going to create my stem, and instead of going 4, 5, 6, 7, 8, 9, I'm going to go 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, and then 9. What we're doing here is we're splitting up each of our tens values, our 40s, our 50s, our 60s, into 2 pieces. So my first 4 is only the values 40 through 44. And my second one is the values 45 through 49, and so on. So I have those less than 45, those more than 40, those less than 55, those more than 55. So now when I redistribute my data, this is what it looks like. And now you can see the distribution is still symmetrical, but maybe we have a better idea of where the true maximum value of the true center is and what the true variation is. It didn't change the shape too much though, so I wouldn't say that it was hugely important that we did it that way. Moving on. In this set of data, it asks us to do the same thing. I'm going to move along to something new. This is a huge set of data here, and it wants us to make what they call a back-to-back stem plot. So with a back-to-back stem plot, our stem is still going to contain all the numeric values minus their last digit. So notice in this data set, we have a tens place, a ones place, and then there's a decimal with a tenths place. We have 3 digits there. So all of my stem has to include all the digits except for the last one. And the last digit on this data set is actually the tenths place. So our leaves are going to consist of those tenths values rather than the ones place values. And to do a back-to-back stem plot, on the next page, they have the stem made for you already. So there's all of our tens and ones places. We're going to add tenths places. And we're going to put leaves for the western states on the left-hand side of this stem, and then leaves for the eastern states on the same stem and leaf plot, but on the right side of this stem. So when I do that, this is what it looks like. And see, the data is very spread out here, but on the left-hand side, I do have my least leaf first, and then it's growing outwards to the left. And on the right, it's doing the opposite. It starts with the least and then grows to the most. So the order is still important on those leaves. But again, with this stem and leaf plot, I really don't see a shape at all. There's not enough data within each piece of our stem to make any kind of judgment about the shape of this. One thing that we could do to make this data look a little nicer is we could go back and take these data values and maybe we should round these to the nearest whole number, which will put more value into each stem. So essentially, we'll condense this data and hopefully we would actually see a shape. So if we want to spread data out more, then we can repeat the numbers in our stem to do that. If we need to condense data within a stem and leaf plot because it's too spread out, then I would round to the next unit